All right, let's jump right in. If you're an architect or designer studying for the AREs, you know fire protection is a huge deal, but it's not always as easy as just throwing in a standard sprinkler. Today, we're going to build out your architect's toolkit with 4 specialized systems that you absolutely need to know.
So let's start with a really important question. You've designed this incredible building, and you've put in a fire protection system to keep it safe. But what if the very thing you're using to protect it, the water, could actually be just as destructive as the fire itself?
And this, right here, is the core of the designer's dilemma. On one side, you've got the absolute catastrophe of fire, loss of life, loss of the building. But on the other, you have the very real risk of water damage, especially if you're talking about server rooms, priceless art collections, or facilities that just can't afford to be shut down. This is exactly why one size does not fit all.
So here's our game plan. First, we'll touch on why standard sprinklers sometimes just don't cut it. Then, we'll break down our 4 key solutions. Dry pipe for those freezing conditions, pre-action for protecting super sensitive stuff, deluge for those really high hazard situations, and water mist, which is a more high-tech approach. Then we'll pull it all together with a decision matrix that's going to be perfect for your exam prep.
Okay, so first things first, why do we even need these other options? Well, your standard wet pipe system, the one where water is sitting in the pipes 24/7, is great for most situations, but it's got 2 Achilles heels. First, in unheated spaces, those pipes can freeze and burst, and second, if a head gets knocked off by accident in, say, a library, well, that's a disaster. So let's grab our first tool from the kit, the dry pipe system. This is your go-to, #1 solution for any space where you can't be sure the temperature will stay above freezing. The idea here is actually pretty simple, but it's really clever. Instead of being full of water, the pipes are full of pressurized air or nitrogen. That pocket of gas acts like a stopper, holding the water back at a main valve that's kept somewhere warm. No water in the pipes means, you guessed it, no freezing.
So what happens when there's a fire? Well, first, the heat from the fire pops a sprinkler head. Then, whoosh, all that pressurized air rushes out. That sudden drop in pressure is the trigger that tells the main valve to open up. Finally, the water floods into the pipes and sprays out onto the fire. The key thing to remember here for the exam is that there's a little bit of a delay while that air gets out of the way.
So, where are you going to specify these? Just think about anywhere that gets cold. Parking garages, open loading docks, unheated attics, and big commercial coolers or freezers. Basically, any place that might dip below 40 degrees Fahrenheit is a perfect spot for a dry pipe system. But, of course, there's always a trade-off, right? The big pro is a no-brainer. You don't have to worry about frozen, bursting pipes. But the cons are really important for an architect to weigh. The water takes longer to get to the fire, the whole system is more complex and costs more to put in and maintain, and this is a big one. Because the pipes are full of air and moisture, they're much more likely to corrode from the inside out. Okay, onto our next tool. Now we're talking about the pre-action system. This one is all about protecting those places where an accidental water leak would be an absolute catastrophe. Think museums with priceless paintings or data centers that run our entire world. I want you to think of a pre-action system like a bank vault that needs 2 different keys to open. It's a dry system just like the last one, so there's no water just sitting in the pipes. But here's the magic. It needs 2 separate things to happen before it will release water. This gives you an amazing layer of protection against a false alarm, like if a forklift accidentally breaks a sprinkler head. Now for the exam, you've got to know the 2 main types. A single interlock system uses a detector, like a smoke detector, as the first key. When that goes off, it lets water into the pipes, basically getting it ready to go. But the water only comes out if a sprinkler head also melts. Now a double interlock system is the Fort Knox of sprinklers. It needs both the detector to go off and a sprinkler head to pop before it will even let water into the pipes. Maximum security. And hey, pay close attention to this one. This is a huge exam tip. For really cold freezers, way below freezing, a double interlock system is the standard. Why? Think about it. If water accidentally got into the pipes in that environment, you'd get a massive ice plug, and the whole system would be useless in a real fire. This system is designed to stop that from ever happening. So the main takeaway here is pretty clear. Whenever the cost of an accidental water leak is just astronomically high, pre-action is the system you want. We're talking data centers, museums, historical archives, you name it. Any place where the stuff inside is just too valuable to get wet. All right, let's do a complete 180. If the pre-action system is all about being careful and precise, the deluge system is, Well, it's about total, overwhelming force. This is the heavy artillery you call in for the most dangerous, fastest-spreading fires imaginable.
So what makes a deluge system so different? The sprinkler heads are always wide open. There's no little glass bulb that needs to break. The pipes are normally dry, but when a separate detection system, like a smoke or flame detector, senses a fire, it trips one giant valve. And the result? Water explodes from every single sprinkler head at the exact same time, completely flooding the entire area.
You're going to see these systems in places with extreme fire hazards, where you need to cool everything down immediately to stop a fire from spreading like wildfire. We're talking aircraft hangars with tons of jet fuel, chemical plants, and around massive power transformers. These are places where a fire isn't just a fire, it could be an explosion.
Okay, for our last tool, let's look at something a bit more modern, a bit more scientific. This is the water mist system, and this is all about fighting fire with finesse, not just brute force. So instead of drenching a fire, a water mist system uses super high pressure to create this fog of incredibly tiny water droplets. And this mist is amazing. It attacks the fire in 3 ways at once. First, it cools the fire down super fast. Second, the tiny droplets instantly turn to steam, which chokes the fire by pushing away the oxygen it needs. And third, the dense fog actually blocks the radiant heat from spreading. It's a seriously efficient way to put out a fire. And the pros here are just massive. You're using up to 90% less water, which means way, way less property damage and cleanup. But, and it's a big but, the trade-off is a much higher initial cost. Plus, these are often very specialized proprietary systems, and they have to be designed very carefully because their performance can be affected by things like airflow and room size. Okay, that was a lot, I know. We've covered the 4 big tools in our specialized kit, so now let's put it all together in one place with a decision matrix. Honestly, this is going to be your best friend when you're studying for the exam. First up, let's talk about the cost. As you can probably guess, as the systems get more complex, they get more expensive. A dry pipe system is a step up from your basic wet system. Pre-action is another step up from that, and deluge is usually the priciest of these first 3. And then, as we just talked about water mist systems, they typically have the highest upfront cost of them all. And this slide right here, this is the one to screenshot. This is your cheat sheet for the ARE. Let's run through it real quick. Dry pipe uses air in the pipes. You use it in freezing areas, and it has a medium cost. Pre-action uses a 2-step activation. You use it for sensitive assets, and it's more expensive. Deluge. All the heads are open. You use it for high-hazard areas, and it's very expensive. And finally, water mist. Uses a fine vapor. You use it when you need to minimize water damage, and it has the highest price tag. It's all about matching the right tool and the right cost to the right risk. So there you have it. Your toolkit is now stocked with 4 really powerful specialized fire protection systems. The real question is, the next time you're sitting down to design and you're faced with that unique mix of risk and value and environment, which tool are you going to reach for? Thanks for joining me.